Hello friends, so we'll be starting our new series on a new tool and learning the new tool of electronics. It's very important in electronic and communication engineering or as well as for electrical engineering. If the engineer is going in a circuit simulation of domain. So the tool is LTSPICE and the tutorial series will be covered on what is LTSPICE and how you can implement the circuits and how you can simulate and see the waveforms and derive some inference from this simulated circuit. So today's content will be including like what are the downloading steps, what is the LTSPICE, then familiarizing with the platform, what are the components, then diode IV characteristic. One of the example we can see to get introduction with the LTSPICE. So first of all, let's see how to download this software. You can simply go to the Google Chrome, right over here, LTSPICE download, and like this website, go to LTSPICE download, click on here, then scroll a bit down. It is a free software. It's given over here that what it is, and read it and go through it, and you can click over here. As soon as you click over here, .exe file will get downloaded. I can show you. Oh, sorry, it is yeah, it is here. You can click over here. It's downloaded, available. Your download has started, and yeah, you can see over here that LTSPICE exe is getting downloaded. It is 44.6 MB of file. It will not take much time to get downloaded. So what is a SPICE? So SPICE is an acronym for Simulation Program with Integrated Circuit Emphasis, and it's a simulation environment designed to replace the need to breadboard designs, which has become increasingly difficult as design complexities have grown. So breadboard designing and looking at the waveforms is now a conventional thing. So it is replacing that complex thing. So that is why LTSPICE tools are introduced. So meanwhile it is downloaded, you can open it and you will see one window is popping up. You need to accept this and decide the location that you need to decide where you can store this um, software file. So you can either browse in which location you need to install. As I have already installed, I am not reinstalling it, but after this you need to just uh, next and finish. You are very expert in this, and this is very simple software, and because you can do it easily. So like we can switch to the second thing, what is LTSPICE. So now you are ready with the downloading steps of the LTSPICE software, and now we can see what is the LTSPICE and how to work over it. For that we will go to this LTSPICE thing. So what does it provide to the designers? So many circuit designs include analog circuits as well as digital processing and digital control systems. So systems that might be thought of as purely digital, such as sensor controllers and multimedia interfaces, all include analog circuits, continuing to drive the need for a simulation tool such as LTSPICE. Here are some of the common analysis we can do over here is transient analysis, AC analysis, DC sweep, noise analysis, Monte Carlo analysis. So this is a very high, this is not very complex. Once you learn the basic thing, you can also design the complex circuits over here, over this platform, and we can check the waveform for that also. So let's start. I have opened the LTSPICE and you can see. Before that, if you face any difficulty, please let me know in the comment section if you are not able to download the LTSPICE properly. Okay. So now we can click over here for a new schematic, or either you can click over here from the file, new schematic. Click over here. This is the new schematic. This is a platform where you will keep and place your components and create one circuit. So what is our next target? Familiarizing with the components. Let's do this thing. So as of now, these targets are finished and that is done. So here, this is the toolbar I will make you introduce with. This is for the new schematic. This is to open a new file. From here we will save the file after creating the circuit. These are the control panels. Different things are available over here, like when you convert your circuit into symbol, and then you can use that symbol in some other circuit directly. Then this is to run AC/DC and simulate and see the waveform. This is for zooming. This is for pan and then zoom back and then zoom full extent, and where to see the visible tracks, splitting the waveforms, uh, cut means if you want to delete any component. This is for copying. This is to do the paste, and these all other components you will learn while building a circuit step by step. But the most usually and mostly used components I'm making you familiar with. That's why. This is the wire for connectivity purpose. This is ground. This is label net. You need to label it is node A, B, C. Then this is the resistor, then capacitor, inductor. This is the diode is given. These are the basic components, so it is given over this panel. From here we will select. We can multiple number of components like with different specification. The simulation will also lead to NMOS, PMOS, so LED. You can gradually we'll see that also. This is for moving purpose. This is for dragging purpose. This is to undo and redo your designs. This is for mirror effect, like if you want to rotate your design towards x-axis or y-axis for that purpose. If you need to mention some text, so for that this command will be used, and dot OK is for spice directive. From there you can directly write acdc.ac.ac those commands, or you can also simulate from this simulation tool. So this is the introduction to the components. More introduction we will see further while building step by step circuits and learning in the different tutorial. As of now, this is tutorial 1, an introductory session. So this much is enough for you. Now the second, next and the last target is diode IV characteristic, forward and reverse bias. So we go to the platform, and here what are the all other things you have studied in your basics. You will need a diode. So click Ctrl R to rotate it for a desired direction. We want this direction, and then left click to place it over the design schematic. Then select the resistor. This we need in such form only, so we can press over here and escape. Then from the components we need voltage. We click OK and place it over here by clicking the left right click and escape. Now we need a wire to connect all these components. Connect like this. Extended a bit, but we will. Okay, nothing to worry. So I have dragged it a bit more. So to remove such type of extra wires, we can use a cut tool. You can see it is simply cut it off, and press escape. to get released from the last selected tool, and then you can throw this remaining wire and click escape. So R value I am taking is just 1 kilo ohm. Okay, how I took this? Press, keep this cursor over here, mouse over here, and then right click. Right clicking will give you this dialog box which will ask like what are the tolerance values, or you can select resistor from here. This much is the content you want to take, specification. So you can directly select from this panel also, or you can give the value from here also. Fine. And then you need to click OK. Likewise, go to the diode and right click and pick a new diode. These are the multiple number of diodes are given over here. Then a diode is also given over here, and it is all given over here. As of now, we are taking this 4148, and then click and voltage. Voltage I am, let's say I am giving the maximum value as 10 volt. Okay. And the most important thing, don't forget, is ground. Otherwise, your circuit will be in a floating state, and it will show error. So now we need to do a DC switch. What is the characteristic of this? What is the characteristic of this diode? So this is the characteristic of diode as such. Right? We need such characteristic in the forward region, and then it should show a reverse bias. State is this condition. So let's see if we are getting the similar waveform or not. Go to the simulate and run. It will open up a edit simulation command. Go to the DC sweep, and then here you need to give the value of the voltage, name of the variable which you need to see. Like this will be in a x-axis. So this is the DC sweep linear. Starting value I am giving it as, let's say, -10, and stop value I am giving it as 10, and incrementing it is 0.01. This is the number of slots by which you can increment this graph. Either you can take 1, 2, 3, but minimum is the increment. The more smoother the graph you will see. Okay. Now you can see this window is opening up. Okay. Before going further, I would like, if you want to save this, you can use this save symbol command is available over here. So to save your design, if so that you can use it further and open directly. So now what I will do is, this is the probe that shows to measure the voltage. When you yeah, move it a bit, and you can see this symbol changed into an arrow which shows the measurement of current. So as this is a DC sweep, you can see on the x-axis as a voltage. This is the supply voltage. So let's see what is the current we are getting. So yes, this is the right current we are getting, right? Let's see. We can label the nodes at diode, and we can measure the current with respect to the voltage across diode. This is the voltage with respect to the supply voltage. Sorry, this is the current with respect to the supply voltage, but we can check with the current with respect to the voltage across diode. For that, we need to give the two nodes. Okay, then rerun it, and what you need to do is move your cursor over here on the x-axis. You can see this yellow thing, scale, and then right click. Now on the quantity plot, you need to change this value, like voltage from X minus voltage from Y, and then OK. Now you can see that the curve is smoother, and this is what we wanted. Fine. Now let's do it by reversing the direction of this diode, and that will turn out into reverse bias diode. And let's see then what is the waveforms. I'm closing it as of now. You can take a screenshot for the study purpose. So for this, I will use this move button and select this component. So now you can see it is moving using the cursor, and control R. Again control R. So this is the desired direction we want for diode, and then you can place it over here and escape, and then run it and see the current, right? And you can change this X minus voltage and OK. So you can see this is the 0 milliampere of current in axis, and it is going in the third quadrant, right? And this is the means the breakdown voltage for this diode reverse bias condition. So this is exactly matching with our theory in the reverse bias condition, and this is as such. So guys, this was the basic and first tutorial of the series on what is the LTSPICE, how to download it, what are the components it is available. Like we will switch to the MOSFETs and filters and amplifiers also, but this is for basic learning purpose. One by one, we will take a complex circuits also. So for that, you need to stay tuned, keep practicing, and do write in the comment section if you face any difficulty. Do subscribe the channel, share with your friends, and keep learning. Stay safe. Thank you.